Good day, viewers. You are welcome. How to solve these interesting nested radical equations where we have a multiplied by root a inside root a equals 2. So to solve this kind of a problem, so we are going to apply two different methods to solve this. So let's say we consider method 1. So for the first method, we are going to take the square of both sides. So by taking the square of both sides, so we have a root a all raised to the power of 2 equals 2 to the power of 2. So by property of indices, it shows that this a is taking the power of 2 and the whole of this is also taking the power of 2, which is root. So we have a to the power of 2 multiplied by root a raised to the power of 2 equals, so 2 to the power of 2 is 4. So next we have a to the power of 2 multiplied by, so this cancel this, as we have this as a root a equals 4. So the next thing here is we also try to take another power of 2 to both sides just to get rid of this root. So here we have a to the power of 2 multiplied by a root a all raised to the power of 2 equals 4 to the power of 2. So with this, so this is also carrying another square, as we have a to the power 2, then all raised to the power of 2 multiplied by, so this a is also carrying power of 2 multiplied by root a, so which is also carrying power of 2 equals, so 4 to the power of 2, it gives us 16. So with this, we are going to multiply 2 by 2, as we have this as a to the power of 4 multiplied by a to the power of 2 multiplied by, so we get this cancelled as we have only a equals 16. So far this is raised to the power of 1, so we apply the basic rule of indices, so which we have the same base, different power, though we have the power together by taking one base. A to the power of 4 plus 2 plus 1, that gives us 7 equals, so let's express this as 2 to the power of 4. So 2 to the power of 4, it gives us 16. So then to get the value of a, we have to take the 7th root of both sides. So by raising both sides by 1 over 7, we have this as a to the power 7 raised to the power of 1 divided by 7 equals 2 to the power of 4 raised to the power of 1 divided by 7. Then 7 cancelled 7, as we have a equals 2 to the power of 4 multiplied by 1, we get 4 divided by 7, and here is the result to this problem. So, and also when we consider the second method, so which is method 2, when we write the question as a root a equals 2. So looking at this, let's say we write this as a multiplied by, so this is one root which is having this a, so we separate this one with its own root, and while this one is covering with two roots, that is, we have root of root a equals 2. As we know that, so the root here is known as the power of half, and a here is known as power of 1 multiplied by a to the power of 1 divided by 2 multiplied by, so we consider this as a to the power of 1 over 2 raised to the power over 2. That gives us a to the power of 1 divided by 4 equals 2. Then we also apply the rule of indices, so as we have a to the power of 1 plus, so multiplication changes to addition, 1 over 2 plus 1 divided by 4 equals 2. So from here, the LCM at this stage is 4. So when we find the LCM of this is over 1, so 1 in 4, that gives us 4. 4 multiplied by 1, we get 4 plus. So 2 in 4, that gives us 2. So 2 times 1, we get 2 plus. So 4 in 4, that is 1. Then 1 times 1, that is 1, equals 2. So next we have a to the power of, so 4 plus 2 plus 1, we get 7 over 4 equals 2. Then to get the value of a, let's raise both sides by power of 4 divided by 7. So just take the reciprocal of this in inverse form. So as we have 7 divided by 4 raised to power of 4 divided by 7 equals 2 to the power of 4 divided by 7. So 4 cancelled 4 and 7 cancelled 7. Then we have a equals 2 to the power of 4 divided by 7. So we get the same result as the first method and the second method. But which one is more efficient, more effective between these two methods? So we have to comment in the comment section below, so to see which method is most preferably to use. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell for more videos. See you in the next class. Never